Swayam Prabha. Digital India. Educated India.
Welcome back, students. We started our discussions on the fruit flotation techniques, magnetic separation, jigs and thickener. In the last class, we talked about the fruit flotations and magnetic separations. To continue in these discussions, let us go for talking about jigs and thickener and how this our mineral processing system, these concentrating devices work. Let us start with jigging today. In the jigging, you will often find in many of the coal washing, you know that in our Indian coal, which are having a high percentage of ash, to remove that ash, we need to wash this coal, and for washing that coal is nothing but again a gravity separation, in which you know the coal particles, they have got a density 0.9 to 1.1, 1.2 like that, depending on the type of coal. But the associated with coal, you are having often sandstone, shale, these particles, they have got higher density. Sandstones may be going density up to 2, 2.4. So, that is why if you can make that systems to you have got this crust to certain extent, so that you are liberating those out, that crust coal, when they are introduced to a device which is named as a jig, and in that they are washed, and then that is a what is done, they are washed with a pulsating water. That is what is the main in jigging. The basic jigging process, that your coal and the non-coal material in a crust, for they are introduced into the jig, and the jig is nothing but a open tank filled with water. Now, here exactly that normally the water which may be coming there as a pulsating water things, it will be coming over there, and then when that the thick bed of quartz particles is placed on the perforated horizontal screen. You can see here there is a jig screen. On in that screen there are these perforations are there. Now, the feed material is placed from the top, and water is pulsated up and down, and the jigging by pneumatic or mechanical plunger. When you will give it over there, the feed move across the bed, and then the heavier particles penetrate through this, and then because it is all the time water it is coming, you are keeping the perforations clean, and then the lighter particles, low density particles like coal here, they will be getting at the top, and they will be taking it out. Now, the concentrate is removed from the bottom, that is a one, you can take out that heavier particles from the bottom and the lighter from this. So, this is what is a basic jigging process. Now, there are different type of jigs. Say, I think in the previous I named about the bound jig, which is used maybe there, I think if I am sure in Radarappa colliery of our central coal field, most probably is having a bound jig there. So, you may find out that exactly in the coal washing, in the coal washery and coal handling plant, lot of this bulk material handling operations are there. There you can make a study or case study if you take up for some of the washery, you will be knowing much more about it. Now, This why we go for a jig out of that. Sometimes when your coal is crushed and then in the tailings all the fines are going, you cannot separate it out. There also this jig called calci jig, that because they use a centrifuge principle also attached, and the jigging with centrifuging is done in this calci jig, and the construction basically what it is here, your feed material is coming over here. Now, this when they will go, there will be the ragging part is here, where you have got a thick bed of quartz, heavy particles are kept over here, and then the feed material, when it will be going over this, they will get concentrated, and then the clean coal will be coming out over here. The dirt, that is high density material, which gets separated out through this jigging process, they are going out over here. So, that is how your distribution of the feed distribution plates, depending on this control, you can control if the sizes and all are different. So, the main operating variable is here, what is the centrifugal force, how you are rotating that, and then what is that ragging, how you are doing it there, how the quartz particles are kept over there, and then how the size distributions in the original feed is there, depending on this jig operates. But the basic jigging I told you, introduced in the earlier case. Then another thing is the thickener. This also I told you, a thickener is an equipment of for structure used for the continuous gravity settling, that fine particles, they need to be now separated, because when it is in the after it is coming as a slurry, in that lot of your fines and solids are there. So, they are used by decantations, they are kept in a tank like that, and by that you can exactly that your material, the fines with water, it is introduced over here, and then they will be getting that. So, there can be scrapers for the whatever the material will get deposited over there, that can be scraped down, and there will be the underflow. After settling it out, this the water or that which will be coming free of particles, they can go over there. In that you can use sometime coagulator, so that you can get the fine particles get joined together to make a heavier and to settle. Things can be done in a thickener. So, thickener is nothing but mainly those very fine particles to be made them to decant and then come, and then as a sludge they will be taken out from the thickener. So, this I told you earlier, that is your feed is coming, that you can get the things collected at the bottom as a thick particles, and you can take it out. So, gravity thickeners consist of the open tanks with feed inlet at the top and a means of collecting of sludge at the bottom. So, you will be keeping a gate there at the bottom, so that it is closed. You are allowing a time for settling it down, and then how the settling takes place. Sometimes you add the settlers, that is you as a coagulator, so that they can be taken up quickly. That is the efficiency of a thickener will be how much less time it will take for separating them out for decanting. Now, there could be the gases that may be associated with, for making them to escape, we will have to give some provisions. There could be sometimes that you may need to take steering also, and then if it is a very heavy, a lot of sludge have come over there, that the evacuations may not take properly. So, there you can use some scraper and others, so that you can scrape down the slabs and put it over there. So, lot of other engineering arrangements can be done over there. Now, that as a conventional thickener, you will see that at the top people can go for inspection, walking and all that thing, a rack will be there, the walkway will be there, and this there will be continuously, you will be making it to very slowly moving, because that particles, they should settle, that coagulations could take place. That is why a very slow motions is given, so that the properly thickening takes place, and then from there, as you say, in the underflow, that will have to be pumped it out by doing this. So, that is a conventional thickener. You can see this in a, if you go to any beneficiation plant, you can see these things. Now, what are the various control there in this? If the this get filled it up, then if it touches this your rake, that is not expected. So, there you can have an alarm, so that there will be overload alarm will be there. You will be controlling the inlet, that the feed coming will be getting, you can stop it. Then you can see that maintain the water level, you can check, that is your when you are giving a feed inlet, and then there will be that you will need to monitoring whether this effluent, where it is properly functioning or not, the whether how you are scraping it out from the bottom, that material which they should not get stick to the that hopper portion of there. So, that is why a structures as a scraper, it scrap it down, and the material it brings to the your discharge phenomena, it is there. So, the whole design, there you can have a lot of innovative way of putting it over there. Now, whatever is available in the field, in the market, in the industry, as a case study, you can see that those are mainly decided depending on that what type of sludge will be coming. Sometimes in some processing, because of the oil and other things you have added over there, they make such a sludge that in that hopper they may get very sticky, it does not flow. At that time, we will have to make the scraping and things like that. So, that the end of the day, you will find the whole bulk material handling is to be solved at the site depending on their problem. You will have to have a basic understanding of what are the methods being used. When you take a specific problem, at that time you will have to take with your pen and paper and start doing sketches and designing. Make the basic sketch that this will be there, then you go for the designing principle, whether it will withstand the strength, whether it will be easy to drive, how much energy will be required, what type of problem may come, like that you go on investigating and get a new system for this purposes. So, for references, a lot of materials are there, some of the websites is there, but thing is that already I asked you to go through the textbooks by mineral processing by Wills, that will help, and also make a habit of looking into the manufacturer's leaflet, though manufacturer leaflet will give you only a superficial informations about it. Once you find out, then you need to explore that as the basic question, how the energy is provided over there, what is the how the capacity has been determined over there, and then how the separation is taking places, what are the principle, if it is a centrifugal separations, that how much centrifugal force is coming up, then in that force what type of particles it can be picking up, what the flow is coming continuously, intermittently, or if that is there, what type of if your evacuations and that your feed, their relationship is how much. Try to find out those variables, and there if when you make the relationship between different variables, then we say that we have developed a model. Once you are getting a model, you can simulate that, okay, whatever that system is taking place in the industry, can I make it to operate in the simulate by controlling the things, can we see the things. So, there comes the simulation. So, those are for your when you go for master's degree, or when you want to do a projects, or you want to do research, at that time you will have to do those modeling and simulations, and then the design control and all. But for the time being now, you must know as a general the knowledge of about all these things. So, I request you kindly start describing the what this is and what are the main components, and what are their advantages and disadvantages. Like that, for each of the system, if you make a note for your learning activity, preparing, that is, you are writing the name or make a column, and then you write for each of these what are the advantages, disadvantages, special construction features, and the basic principle made. These 4 advantage, disadvantages, you can put it there. That first is the constructional special features of their constructions, special, that is your basic principles, then their advantage and disadvantage. And these ones you are doing it for, say, thickener, for the jigging, for this in jigging again you can go whether for the bomb jig or calci jig. So, like that, if you do it for at least there will be 8 or 10 different systems will be there. If you can master, or if you can master one, is very good, but if you cannot master one, at least you know the general knowledge about all of them under this 4 category, make it as a learning point. And with this we conclude about this discussion on the mineral processings, particularly for the concentrating and all. And we look forward to our next discussions. Slowly we will be moving into the transportation sites. Thank you very much.